All right, so we're going to talk about Lewis dot structures, which is something we sort of talked about already, but we need to go back into greater detail about. So a Lewis dot structure is a way that we go ahead and we draw structures that allow us to only talk about the valence electrons. See, strontium has a lot of electrons in it. Strontium actually has a grand total of 38 electrons as drawn over here. The problem is I don't want you to draw 38 electrons over and over and over and over and over again. That will take way too much time. So what I do want you to do is I want you to be able to take a look at these structures and identify what their valence electrons are and do your very, very best to figure out a way to identify the valence electrons without having to draw them. Pardon?
Can you zoom in a little?
Maybe you should move up by Josh. Huh?
You want to move up by Josh?
Maybe you should move up. Can't see.
Doesn't help.
Anyway, so
It's really tiny.
so
But, like,
can I go on now?
Yeah.
So in this case over here, I can see that strontium has 38 total electrons. But the outermost energy level is this one. This is my outermost energy level. And in my outermost energy level, we also know that is the valence shell. And I count that it has 1, 2 electrons. So this atom has 2 valence electrons. So it is 2 valence electrons. So far, so good with that. Okay? Can I go forward?
wait a second.
So what I've done then is I simply took the symbol for strontium.
Why would you use green?
Why not?
It's too like, yeah, that's my eyes.
Wait, what does that say?
It's okay, Mr. B.
It's strontium, all right.
Why don't you just erase the green? Wait, straw, say it again?
Strontium. Strontium.
Is that an N?
Strontium.
Why'd you write it twice?
Because people were complaining it was green.
Oh.
Now,
I don't understand.
with that in mind, with that up here. With that in mind,
I do.
because strontium has 2 valence electrons, I drew strontium's symbol, SR, and I put 2 electrons around it. So that's how I can tell that strontium has 2 valence electrons. It's a newer, quicker way to do this.
What was the old?
The older way was to draw this giant structure, and I'm trying to give you a shortcut.
So you just counted 2 on the other.
He's just trying to be.
Moving on, because I'm going to show you how this works. Now, the very, very first thing that we have to do is we have to write the chemical symbol. So that's what I did with strontium. So I did like SR. Then I have to figure out the number of valence electrons it had. So let's see. Strontium, Strontium, has 2 valence electrons. We'll talk about how to identify that in a minute. And so then I just wrote a dot that around each side of the symbol, starting at the top, then the right, then the bottom of the left, and go like this. So I have 1, 2. So that shows that strontium has 2 valence electrons. The key here is that like something like a noble gas, neon is a noble gas. We talked about that already. With 8 valence electrons. If I were to draw that, I would have neon with 1, 2, 3, 4, 5, 6, 7, 8. That's how you would draw it. It would have 4 pairs of 8, or 4 pairs of 2. But, how do we figure this out? I'm going to give you a cheat code on this, and I'm going to do my very, very best to help you. So, if this is your periodic table, which you don't have drawn in front of you,
Why is the periodic table the way it is?
if you give me a few minutes, I can show you how it really should be.
You want us to write that?
I'm trying to show you guys how to figure this out. supposed to be 1,
There's like a Lewis.
2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. All right, so this would be column 1, column 2, column 13, 14, 15, 16, 17, and 18 on the periodic table. What?
Isn't that how it already looks?
Exactly.
Okay.
Now, what I'm about to tell you is something that is very important, and I'm going to pick a color that everybody can see, and I'm drawing this and helping you. Maybe what you might want to do is flip to the back side of your packet. Note that you have a periodic table already there.
No, no. Wow.
Back side of your packet.
I lied.
Back side of your packet. Get off your phones.
Is black a shade or a color?
It's
Now,
both.
what I want you to see is that in column 1, I'm going to tell you that in column 1 on the periodic table, there's always one valence electron. You might want to write that above column 1. One valence electron. Every atom in that column has one valence electron. In column 2, I'm going to tell you that there are 2 valence electrons. Every atom in column 2 has 2 valence electrons. I am going to skip this portion right here. Don't cross it out on yours, I'm skipping it. Because I said so.
Are we ever gonna use it though?
Yes, but not today.
Why? See, Marco?
Column 13, I'm telling you right now, has 3 valence electrons.
What means it?
Column 14 you're catching on. Column 15,
Oh my gosh.
Six.
We know how to count.
7, 8.
Wow.
I know. Shut up.
okay? So across the top of your periodic table, you should have 1 valence electron, 2 valence electron. Above column 13, 3, 4, 5, 6, 7, 8. Yes?
No.
So far, so good?
I guess.
May I go on?
Sure.
No? Oh yeah, go ahead.
Now, here's the deal. You are going to, for your homework tonight, have to go back and forth between your periodic table on the back of your packet or the one that you happen to have in your notebook or that you saved from first semester, which most of you did, right? Doubtful, okay? Here's the thing. You need to locate aluminum, okay? And if you find aluminum, you are going to notice a couple of things. Aluminum has 13 total electrons, but it has 3 valence electrons, correct?
Sure.
Isn't that what the column says?
Yeah, I kept it.
So when I draw the Lewis structure for aluminum, I'm going to put 1, 2, 3 electrons around it.
Why?
Because that tells me the number of valence electrons.
Oh, I get it.
Phosphorus has how many total electrons?
Wait,
Look on the periodic table.
15.
It has 15 total electrons. How many valence electrons? 5 valence electrons. When I draw this structure, it looks like this. 1, 2, 3, 4, 5. Note that I spread them out and then I doubled up.
Why does it matter?
Because it goes
It,
in order.
because it goes in an order. Because electrons are what charge? Negative. Do negative things want to be near each other?
Yes, no.
No, they want to be far apart. So we draw them as far apart and then we force them together if we have to. That's why. All right. The strontium ion. Oh man, let's talk about this for a second. Strontium. Okay? Strontium has how many valence electrons?
2.
Okay. It has 2 valence electrons. It has 38 total electrons. Right? Okay? Now, here's the problem. Would it be easier for strontium to, or wait, how many electrons does strontium need to gain to get to 8?
8.
It has 2 total valence electrons. How many would it need to gain to get to 8 valence electrons? it would want to gain, I'm sorry, I made it in the wrong color. Oh my gosh. It would want to gain 6 electrons or lose 2 electrons. Which would be easier?
Lose 2.
Lose 2. Does that make sense? So this is going to be easier. So when I draw this, okay, what I'm actually going to draw is the fact that it's going to have
2. What?
Now, don't draw anything yet, because hang on a second, okay? This is what we want it to look like, but what really happens is that strontium by itself, before it becomes an ion, has these 2 electrons, right? So what strontium is going to do is it's going to lose 2 electrons, and when it loses 2 electrons, we're going to write it like this.
So can we start writing?
Wait, where's this?
And now, here's the deal, okay? Strontium, protons, neutrons, and electrons has 38 protons. It has 38 electrons originally, and strontium has, what is it, 88 minus 38? 88 minus 38 is, what is that? 88 minus 38 is 50. 50 neutrons. Okay? Question?
Are we putting this where it says aluminum?
No.
Yeah, and where are we gonna
Just
put them?
pay attention for a second,
So
okay?
we're not writing it down?
Just pay attention for a second, okay?
So we're not
So
writing
pay
it-
attention for a
Oh
second.
my goodness.
So now, here's the thing, okay? If strontium lost 2 electrons, it now has 36 electrons, correct? So what's strontium's total charge going to be? Looking over here, what's strontium's total charge going to be? 38 minus 36
Oh, 2.
will be a plus 2. So because it lost 2 electrons, that's what the strontium ion would look like. So far, so good.
So we can write that
Where though?
There-
in the box.
This is just an example. I'm going to do 2 that you can write in the box now.
Okay, that makes sense.
Next, here's the deal. We're on the next one. We have aluminum, which we know protons, neutrons, and electrons. In a neutral atom, aluminum is going to have 13 protons, it's going to have 13 electrons, and it's going to have, let's see, 27 minus 13 is 14 neutrons, okay? Now, according to what you just learned, how many valence electrons will aluminum have?
3.
Good. Aluminum will have 3 valence electrons. Now, stop for a second. If we draw those electrons, they would look like this. Would it be easier for aluminum to lose 3 electrons to get to 8 or gain 5 electrons to get to 8?
Lose 3.
It would be easier to lose 3. Okay? So when that happens, aluminum is going to lose 3 electrons. When it loses 3 electrons, I'm going to rewrite it simply as Al. Now, if it lost 3 electrons, it's going to have a total of 10 electrons left over, correct? What will aluminum's charge be?
Plus 3. No.
Not plus. Minus 10 electrons will be 3 protons. So it's going to be a plus 3.
Did I say that?
You did, and I was just supporting that. Okay? Now, phosphorus.
What's phosphorus?
It is an element.
Really?
It is a non-metal.
Nine. What?
It is a brittle solid. Phosphorus has 15 protons. It has 15 electrons, and for neutrons, it's going to be 31 minus 15, which is going to be 16 neutrons. Now, according to the periodic table, what we just learned about, how many valence electrons does phosphorus have? It has 6 valence electrons. Does it have 6?
Maybe.
Yes,
Check
it does.
better, check better, check better.
3, 4. Oh, five, my bad.
That's fine.
Oh, loser.
It has 5 valence electrons. Would it be easy, so if I draw this, don't draw anything yet. If I draw this, would it be easier for it to lose 5 electrons to get to 8 or gain 3 electrons?
Gain 3.
It would be easier for it to gain 3.
Why would it lose? That's just more.
No, you can shut up. Shut up.
Could we shutting up, please?
Yes, please. Or yes, sir.
Okay? So it's going to gain 3 electrons, so we're going to have 3 electrons coming in to these spots here. So it'll look something like this. Okay? Now, so in this case, if it gained 3 electrons, it now has a total of 18 electrons. Okay? So I'm going to look at this and say, I have 15 protons minus 18 electrons. It's going to give me a -3 charge, right? So when I rewrite this, I'm going to write it looking like this. Phosphorus,
I thought we didn't have to put that.
You lied.
I never said that. Okay, in this case, because there are electrons left, because the electrons were added, you have to draw them.
We have to.
Okay, but over here, because the electrons were lost, we don't have to draw them. Does that make sense?
Are we gonna lose points if we don't do that?
Yes.
Man.
Questions?